Hello everyone. So today's class we are going to discuss about the extension of metal casting processes. So in last video presentation we have discussed about what is sand casting, sand mold and pattern. So sand casting is making of component with the help of molten metal. So the metal is poured into the mold cavity. Then after solidification we can get the final product. So this is the sand casting process. So the sand casting can be done with the help of molten metal and cavity. So the cavity can be prepared with the help of pattern. So pattern is a model of record casting. So these are the things we have discussed in the previous presentation. So in this class we are going to see about pattern allowances. So what is the necessity of giving allowances to the particular pattern? So generally already we know a pattern is a model of record casting. So what we are going to make as a final product, so we should be done in a model, so that can be preferred with the help of that is prepared with the help of wood, metal, like that. Then what is the necessity of giving allowances? So generally the pattern are not made into an exact size of casting to be produced. The reason is the material having a different nature, so it is going to shrink when the metal is poured. So after solidification what will happen, so it is going to shrink in its size. So if the pattern is made on the exact size of the casting, so after solidification what will happen, the final product will be obtained with the dimensional defects. So dimensional defect in the sense less than the record size. So how it is possible? If the pattern is made on the exact size, so cavity will be created on the exact dimension of the product. So if the cavity is created on the exact dimension after material is poured, so after solidification, so we can get the metal is going to shrink. Then the final output will be the dimension is less compared to the original part. So to avoid this, so we should give some extra dimensions, so that is called as allowances. So we are going to give a dimension, we are going to make a pattern slightly larger than the required casting. So thus this extra size given to the pattern or given on the pattern is called as pattern allowances. So generally this pattern allowances is classified as one is, this is shrinkage allowances. So shrinkage in the sense the metal is going to shrink after solidification, so that is shrinkage allowances. So to overcome this shrinkage issue we should give some extra size to the pattern, so that is called as shrinkage allowances. And the second one is machining or finishing allowances. So this allowance is required because after the metal poured into the cavity after solidification we are going to get the final product from the sand mold. So it looks like it's not up to the mark, so the surface finish is concerned, it is not expected level, so we should be finish it out. We should generally some already we have given some extra sizes to the pattern. So even though the extra size is given, so we should machine as per our requirement, so we should give some final finishing to the final product. So that's why this finishing allowances is required. So the extra size is given to the pattern for material finishing, that is machining allowances. And the third one is draft or taper allowances. So this is required for to avoid the taper, so we will see about this. And the next one is distortion or chamber allowances. And the last one is wrapping or shake allowances. So this is completely different. So this shake allowances is different from all the four remaining pattern allowances. How in the sense, so this shake allowances is called as negative allowances. So let's see one by one. So what is shrinkage allowances, what is machining allowances, what is draft and taper allowances? Let's see one by one. So here the first one is material shrinkage. The first one, it is material shrinkage. So here the extra size given to the pattern are given, or the extra size provided on the pattern for metal shrinkage. So we know the metal is going to shrink after uh, solidification. So if the metal is shrinkage, the metal is going to shrink in the sense what will happen. So it is going to get the reduction in size. So if we are going to make a product, if you're going to make a pattern in the exact size, so the cavities will be produced on the same size. So if we are giving some allowances to the pattern, considering this material shrinkage, so the pattern will be made slightly larger compared to the original dimension. So automatically after the metal is shrinked, we can get the exact dimension of the final product. So for that purpose only we are using shrinkage allowances. Next one, it is machining allowances. The machining allowances is needed for all the materials, especially for cast iron, aluminum, brass, steel, zinc, lead, for all the materials. So we should give some machining allowances as well as the shrinkage allowances. So this table shows the preferred dimensions what we have to give as an allowances for cast iron. For if we are considering the cast iron, so we have to provide 10.4 per meter. Likewise, for if it is an aluminum, we have to produce 17 If it is brass, we have to give 15.3 per meter. When steel, it is 20.8 and zinc and lead, so it will be 25 per meter. In case of machining allowances is concerned, it is divided into two categories. One is up to 300 and another one is up to 600 If our dimension is above 600 up to 600 in the sense, so we should give 4 3.2, 3.2, 3.2, and 4.5 based on the material division. That is cast iron, aluminum, brass, steel, etc. So here we should consider this, what is the base length and what is the allowances we have to give. So that is different based on, if it is 300 we should follow this allowance in dimension, and if it is 600 we should follow this one. The next one is draft or taper allowances. So generally, instead of making a vertical surface in the pattern wall, the final wall, instead of making a vertical structure, so we are preferring the taper form. So this taper allowances is provided on the pattern due to the easy removal of the pattern from the sand. So what will happen if you are making a wall in a vertical manner? So when we are removing the pattern from the sand, what will happen? So there will be an surface defects will be formed on the cavity. So this is an example. So looks like, so if we are going to remove in a vertical way, automatically, so this due to the friction between the pattern wall and the sand surface. So there is a chance for creating this kind of surface defects on the cavity. So if you are noticing this kind of surface defects on the cavity wall, what will happen? So that definitely there will be a surface defects on the final output also. To overcome this issue, instead of making the vertical wall in the pattern, so we are making a pattern in a slightly tapered manner. So if it is for external surface, it should be given up to 10 to 25 For its internal surface, it should we can give up to 65 And the last and very important one is shake allowances. So generally, the shake allowances is called as an extra. Instead of giving extra size in all other allowances, we are giving an extra dimensions to the pattern. In this shake allowances, what will happen? We are going to reduce the dimensions of the pattern material. When we are removing the metal, so we are going to give, when before withdrawal from the sand mold, the pattern is wrapped all around the vertical surfaces to enlarge the mold cavity slightly. So if you are giving an extra size to the pattern, it further enlarging the cavity size when we are removing the pattern from the sand mold. So to overcome this issue, instead of giving an additional size, we are going to reduce the size of the pattern. So that's why this is called as an negative allowances. So here it is called as, it is a negative allowances. So the allowances is the additional size given to the pattern to overcome various issues. Okay. So I think you guys are clear about what is pattern allowances. So here it is a next one is chamfer or distortion allowances. So when we are making a structure like I structure, I cross section one, then T structure or it is an L structure, what will happen? After solidification, there is a chance for material distortion. Sometimes the casting may get distorted at the time of solidification. So due to some typical shapes. So to overcome this issue, we are going to give some additional dimensions to the pattern. So what will happen? So after solidification, the material is going to be taken out from the sand casting and it is going to be machined and we can form the required shape of the pattern. So in this class, we have discussed what is sand casting, what is pattern allowances, and what are the different types of pattern allowances, and how much amount of allowances, dimension allowances we have to give to the patent. So we have discussed in a detailed manner. In upcoming classes, we will see about furnaces and special casting process. So thank you.